Hello, chemistry students. We are back and let's finish up this key talking about electronegativity. So the definition for electronegativity is here at the top, and that definition is that it is the ability of an atom to attract electrons. All right, so let's first talk about electronegativity in periods. How does electronegativity change as you move across the period? Look at period 2 in order to help you with this trend. So before we do that, let's take a look at our chart that we drew. So we're looking at electronegativity across a period. So here it is in green, electronegativity, and it looks like it goes up as you go across a period. So we have to think about nuclear charge, since we're talking about periods, and how would that fit in with the attraction of electrons? Okay, so number one, how does nuclear charge change as you move from the left of the table to the right? Well, nuclear charge is going to increase. And how do I know that? Because the atomic numbers are increasing as you move from left to right across the periodic table. And how does this impact electrons on the atom? Well, the bigger the nucleus, the better those electrons are pulled towards the nucleus. So electrons are pulled toward the nucleus. That is larger. Number 3, how does electron shielding change as you move from the left of the table to the right? Well, it doesn't. Oops, it stays the same. Therefore, how would electronegativity change as you move across a period? Well, as it says on our other document, it increases. And now we need to explain why. Well, here's your explanation. As the atomic number gets bigger from left to right, the nucleus becomes stronger. And the nucleus that is stronger, the nucleus that has more protons in it, is going to attract electrons better and pull them in closer. So atoms that have larger nuclei, that have a higher nuclear charge, are more electronegative. And here's the answer that I created. Bigger nuclei, those with a higher atomic number, have a greater nuclear charge and attract electrons better, pulling them toward the nucleus. So therefore, I forgot this part. Electronegativity increases across a period. All right, there we go. Now let's take a look at electronegativity as we go down a family. So let's take a look at our picture. Here's electronegativity. So as we move down a family, electronegativity decreases. So we have to think about, how does shielding affect the attraction of electrons as you move down a family? Okay, so how does nuclear charge change as you move from the top to the bottom? Well, it's going to increase. But remember, we also have an increase in shielding, and the shielding is going to negate the nuclear charge. So how does this impact the electrons on the atom? So if we have lots of energy levels around the atom, it's going to push electrons away from the nucleus. So how does electronegativity change as you move down a family? It's going to decrease. And the reason is this. Remember, electronegativity is the ability of an atom to attract electrons. But if you've got shielding, it's pushing electrons away. It's doing exactly the opposite of what electronegativity is. So that's what I'm going to write in my blank here. All right, so here's my explanation. Shielding prevents the nucleus from attracting electrons because more energy levels push electrons away, which is the exact opposite of what electronegativity is. So shielding prevents the nucleus from attracting electrons. So it's going to prevent the atom from being electronegative. All right, everyone, thanks for watching this second video. I'm sorry I didn't get it all into one video, but I hope that this helps, and I hope that this helps you to fill out your cheat sheet. Anyway, I'll see you in class. Let me know if you have any questions. Bye.